Good morning. This is Rusty's Repairs, otherwise known as Sherlock Ohms. I bought a bunch of these project boxes off eBay, and I got a couple of emails asking me to review them, and I thought I'd just do some videos and pictures and show what I've created with them. This one is my ATX power supply breakout. I have the +3, +5, +12, -12, and -5 outputs. I added some USB ports to charge stuff with. I don't have a current meter on these other than what's available on the 5-volt rail. Anyway, most of this stuff, you know, I had a bunch of computer power supplies laying around. But most of the stuff I build these with is straight off of eBay in a kit form or something similar. So this is the guts. I've got the ATX power supply. This is, I don't know if you can see this. This is a breakout board that you can get. I'm going to give links to all of these in the description. The panel meters readily available. I think they're running maybe $5 a piece. Not real good quality, but they work if you don't mess with them. And wiring the back panel. And so I got a pretty decent power supply for just a couple bucks. And I'll plug this in and show you what it looks like when it's running. The only trouble I had building this was when I went to hook the plus and minus voltages together on the same power supply. I had to reverse the inputs and obviously ground the hot side of the negatives and read the ground sides to get the correct voltage outputs. If you're interested, leave a comment and I'll show you how I did that. So that's my ATX power supply breakout. Thanks. Next up, let me shrink this down a little. This is an audio generator that I created from a ICL 8038 board. You can pick these up on eBay now for probably less than $5. So I don't have the labels made for the panels yet, but I have, this is the waveform switch between triangle, sine, and square. This is the frequency range. This is a skew for if you have it on triangle and you want to make it into a ramp. This is the output gain. And I don't remember what this knob did. This is probably the fine gain. And I put 3 different outputs on here. I've got a RCA 8mm and a BNC. Now later on I added this. I used to have a frequency counter up here, but it didn't really display the waveform. And when I bought this, I don't know how to pronounce this, Fnurs 3. This one displays the waveform and it'll also give you a frequency output, really tiny on the screen. I think I paid $30 for this. Anyway, I'll plug this in and show you how this works. Okay, let's turn my frequency up here. This is let's see, triangle, sine, square. Now if you're on triangle, this is the skew, and you can angle your ramp left or right. I can get a really good one to the left, but not so much to the right. This would be the frequency adjust. Okay, this would be the range and amplitude. Now if you look down here, you can see that my frequency is 2.37 kilohertz. That's about the only reason I put this on here. Two reasons. One was to get the frequency count and a picture of the waveform. So that's that one. Next up is the frequency counter. Now this is a module you can buy ready-made. You just hook power to it and a signal. It runs usually around 12 to 20 bucks, and you can get them in multiple colors: red, green, blue. I haven't seen a yellow one yet. And this one is listed on eBay. It's a kit for a 1 to 50 megahertz counter, or a crystal. It's set up to read crystals, but you can modify it, and I actually did some mods on the board to increase the gain down to a pretty low millivolt level. Now I kept modifying this. This one I actually made labels for. I ordered some see-through decals off of eBay that you can print with a laser printer or an inkjet. They're like the kind you used to use on your model cars when you built them. So I printed labels and I stuck them on here, but they're kind of raised and they don't look too good. And when I tried doing like a clear coat over the top of them, it ate the bubble paint off. So this is my input. If I go to the left, I can read the high frequencies. This is supposed to go up to 1.8 gig. Haven't had it that high. On the left side, it'll go from 1 hertz to 50 hertz, and it's extremely accurate. I'm just rather surprised. Now the switch on the back, when it's up, it runs this input to the counters. When it's down, I have it hooked to the back, and this one I run a cord out to my oscilloscope. Now most of the newer ones I have a, I don't know, 10 millivolt output or something on the back that you can read your scope with. So if you have an older scope like I do that does not have a frequency counter built into the display, you can use this method to get your frequency count. This is a power supply board I took out of I think it was an alarm system charger, and then I added a 9-volt supply with a regulator here for the crystal frequency counter. Most of these have a, oh gosh, I can't remember the name of these, a C14 computer connector. You can get these off eBay. It's got a fuse built in and an on-off switch and that kind of thing. Anyway, this has been quite useful. Other than the limited input voltage, I can't go down real sensitive, but it's been pretty useful for what I have done with it. And that's about it for that one. So next up we have these two. I bought these off the shelf on eBay or AliExpress, I don't remember which. So this is the Fieldtech 6900 frequency generation. It does have a frequency counter in there, but I found it doesn't work really well, especially on the lower voltages. I brought the back panel outputs to the front, so if you want to do like a modulation waveform, you run a cord from VCO down into output number 2 and use that for your audio or whatever modulation you want. And this will generate just about any waveform you can think of, up to 60 megahertz. Another thing I like is the fact that it has a USB output on the back, and I can run this into my computer and have a huge display up on the screen where I can create just about anything. So I'm going to pause here and get this pulled up on the computer, and I'll show you what it does. So this is the display screen for the Fieldtech 6900. I don't know if you can see this too well, but on the upper left you have your waveform generation for channel 1. On the upper right you have the waveform generation for channel 2. Lower left is the modulation type, and you can do all kinds of stuff with this thing. And lower right is the frequency counter. Now you have these individual windows, or tabs I should say. Right now we're at the control window, and you can do a waveform build. I haven't played with this, but I assume you just draw what you want the waveform to look like, but not sure. And then you have a text window. Totally don't understand what that's about. I think it's for programming. Mostly I use this window for my wave generation and control, but it's really nice having this on the big screen because I'm getting old and don't see too well. Also, a lot of the newer tools that I have bought, including some scopes and even the voltmeter, will have a display like this built into it. You just got to find the software. And that's it for that one. So this is my OWON digital voltmeter. It's got a 5-digit count or display. I like this because it's extremely accurate down to, well, usually less than a millivolt. The downside is it takes quite a while to count that high. If you want a stable voltage reading, it could be 2 to 3 seconds before it reads it accurately. The capacitor setting on here is a joke. I haven't been able to read anything with it. And the frequency counter, somewhat. It does work, but you need a pretty good voltage going in to even count anything. Other than that, I really like this thing. It was about $100 or so on eBay. I think I got it from Alibaba, AliExpress, something like that. You know, through eBay. But it was definitely well worth the money. So there's that. So next up, this is a tiny SA that I just put in one of these cases. These are your inputs, high and low, power switch. Really hard to see. I'll zoom in here. But like the last one, this one also has a USB output. Actually, it's powered off a USB cord. But I will stop the camera and bring this up on the computer so you can see what I'm actually seeing. So this is what the display looks like on the computer. Also runs on a USB, and this is a big display. I think my screen here is 24 inches wide diagonally, so you can get a definitely good look at what you're scanning, and it's completely adjustable for your floor, your frequencies, how fast you scan, what band you scan. Really awesome. I mean, for what I paid for this thing, it performs incredibly well. So that's that one. So next up, this is I can't pronounce it, SL 20401 frequency counter. I have all the modules in it except for the time base that's accurate to like 1 part per million. So you have a high or a low frequency input, high frequency input. This is your gain, I guess, or limit. Then you have your adjustments. This is a magnet my granddaughter stuck on there. But this is supposed to go up to 5.8 gigs. I haven't had it anywhere near that high. But this was about $100 in a kit form from Germany. Had to wait a while to get here, but it wasn't too hard to put together, and it does work really well. I'll plug this in and show you. So there you can see the readout. That has channel A is the low band, channel B is the high band. have to have that extra module to get the high band to work. I guess it's basically a down converter. Anyway, this one also connects to the computer, so I can have the display on the PC screen. But I cannot get this software to work yet. There's probably 8 or 10 different drivers for it, and I haven't found the one that works correctly. So if I do, I will probably post a video of this later. That's it for this one. Next up, this is a dual, I believe it goes 0 to 30 or 40 volts. It's quite a bit, and up to 5 amps with current limit and voltage adjust. These were kits that I purchased. I think the hardest thing I had finding was the transformers. Some of the stuff's out of the junk box. So I had some computer fans. I had the heat sink. The kits, I want to say, were about $20 or $30 a piece. And so I had 2 transformers. These actually power, they changed the circuit diagram on this. They used to have like Zener diodes and dropping resistors to power the minus and plus 12 volts. But then on this version they changed them to voltage regulators with a little bit of heat sinks down here. The other problem I had found was when I hooked up the thermal diodes that kicked the fans on, they had them running in reverse. I don't know if they had a negative temperature coefficient, but when the heat sink heated up, the resistance increased and they never turned the fans on, which is not good. But I kind of like stuff like this where they screw things up, because that gives me a chance to improve my skills on figuring out what went wrong. But this is good for probably 10 amps. I've got each transformer for each power supply. And you know, I don't know why, but a lot of the ones that I buy off the shelf are limited to maybe 2 amps or less. And a lot of stuff that I run, like car amps or whatever I have to power, it does not work well on 1.5 amps, and that's frustrating. So thus I built this thing. Now I also have over here a very expensive Hewlett-Packard, what number is this? 6255, and it's a dual power supply with adjustable current and voltage, but you can only get 1.5 amps out of it, maybe 1.75 amps, which still isn't enough. I can't even charge my cell phone on it because it doesn't put out enough current. Anyway, this took a while to build. Got the power meters off of eBay. Strictly DC up to, I want to say these were rated at 60 volts. Let me get this plugged in and I'll show you what it looks like. So just for kicks, I'm going to dial this one all the way up. So yeah, about 35 volts. And pretty easy to read display. The only thing I think I would change at this point is I would get different knobs on here. And it does come with LEDs for current over voltage, whatever, overload. Really handy supply, wasn't hard to build. It just, like I said, I kind of like the challenge of figuring out where they screwed up their circuit. And it was interesting, but I got it all working. The fans turn on. I'm really happy with how this turned out. So that's for that one. So next up, this is a dummy load I built to test the power supplies that I build. Believe this kit came from Thailand. Don't remember. You can get them on eBay now from China. But it's basically, you provide the heat sink and the fans and connect the boards. And I don't know how high a voltage this will test. Most of my power supplies are less than 50 volts. And then down here you have the load adjust, and I put a 10-turn pot in there, so I can run this anywhere from 0 to 10 amps. And because it works so well, I bought some more heat sinks. and another board so I can double the load rating on this thing. I believe this is rated at 150 watts between the voltage and the current. Anyway, it works really well and I'm quite happy with it. So that's it for that one. The next up, this is a, I guess you'd call it a station monitor. I ordered a special dual SWR meter. Now this is interesting because you set the SWR, but you don't have to set the power. SWR will read down here, and the power is just whatever you select it for. And because it goes to a 300 watts, I put a high and low in there, so I can go either 30 watts or 300 watts. This is your stock frequency counter module that I used in the frequency counter build. Another thing I want to add is, say, maybe a scope output on the back. So you go to oscilloscope to watch modulation percentage. I still have a bunch of panel left. Thought maybe putting in a external speaker, just mainly for CB radio, but I guess it would work with probably anything up to 100 meters. So there's that. Now this one I am quite proud of. I watched a video from Learn Electronics Repair from, I think he's in the Canarian Islands. I didn't watch him for a while because his accent was so thick I couldn't hardly understand, but now I'm catching on. And he built one of these, not quite like this, but similar. So once again, you have the crystal control module or measurement module that goes from 1 hertz to 50 megahertz. Now inside, I used 3 of those ICL 8038 boards. Each one is adjusted to a different frequency. Over here I have a audio amplifier to control the gain, and over here I have a 555 timer for switching. This is the split power supply. Now the ones you can buy of these now actually come with the relay. What I did, I built a little board for the inputs, or actually outputs. These go to the oscilloscope because I didn't want to go to the trouble of building a tube in here. So the way this works is very much like a Huntron with maybe a little more complexity. So I turned it on. I got my frequency selectors here. I think I run 400, 1,000, and 4,000 or 5,000. Now this one, I think this is your voltage output level that runs off the audio amp. And then you have your X and Y's outputs here. Now, so this is going to be your A input, this is going to be your B input. These go to the scope, and when you select this, you can have A on or B on or both. And when you have it both on, the 555 timer, I have it set for a 50% duty cycle, and the relay behind here is going to switch from one channel to the next. So if you're, say, troubleshooting a stereo, you can go to channel A and channel B at the same point, and it'll switch between the 2 readings, and you can look on your scope and see which part is defective. And this wasn't really that hard to build. I want to say I've got probably easily less than $100 in kits in here. Probably closer to around 50. Anyway, that is one of my favorites. That's it for that one. So over here is another build. This is not the same case size, but it's the same manufacturer of the cases. This is an antenna switch. I bought one as a 3-way, and I quickly outgrew it. You know, you got your dummy load, your outside antenna, your test equipment, blah 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 blah. This one is a 6-way. I have colored LEDs for each whatever switch position I'm in, and this is on the back. This is my input, and this is whatever I select it to. and it works off a 5-volt supply, I believe, maybe 12. And so when you turn the knob, you're switching your 12 volts to each individual relay. And one thing that's cool about this, when you switch to one input, it opens the relay to that and it grounds all the other relay inputs, so there's no noise or anything can get into the system. And that is really well thought out. So there's that one. So this one is a Variac combination isolation transformer. I have the power on switch, adjust the voltage here, the voltage meter, current meter, and if I don't have any issues I can bypass it and run it straight through without the light bulbs. Light bulbs are up here. And I put 2 sockets in so I can actually change the light bulbs out to whatever wattage I need to limit at. Now this here is a power current voltage watt meter. I had to hunt quite a bit to find this one because this will read down to 0. These two are only active when the Variac is turned up, and it does not read any current or whatever until you get up to about 50 or 60 volts. So this is very nice. I can have a 20 or 30 volt setting, and this will actually read how much current and power is being used up way before the light bulbs come on. Anyway, this I will post a schematic for. So I have the Variac, and inside there is an isolation transformer, so it's completely isolated from anything on the bench. That is nice. Thanks for watching. So yeah, I forgot to include some pictures of the back. Inside here basically I have a SWR meter board out of an old Radio Shack handheld, and this I hooked up with a wire loop so it doesn't like actually drag down the signal going through. And this feeds into the oscilloscope to watch the signal. So when this is all said and done, I drilled holes through the bottoms and tops of each case, ran it through the feet, and made little stacks of 4. So there's one set, there's another set, put the scopes on the bottom, and there's another set. I got the tiny SA on the top, and in the next shop, room next door, I have 4 more boxes to build stuff over here. But I'm getting kind of picky at what I build because the boxes are getting pretty expensive and kind of scarce. I think I might do a transistor tester and maybe a milliohm meter, and we'll see what the future brings. Thanks for watching.